So now we have a solution that works, and it was when I submitted, it was accepted, but it was not very fast. So here I think is the result from this submission. So in LeetCode they show this the running time and memory of the submission, and I think when you submit, they show the percentage. So here the submission the solution I just shown is not among the fastest, so it's faster 76% of all the C++ submissions. So now how do we improve the accuracy? No, I mean how do we improve the performance? How do we make it faster? So I took a look at the one of the faster solutions. Actually, you do that by clicking on you can click on this and then you can look at the solutions. So then I realized what could be done to make it faster. So we're not using all the conditions they are given. So in fact, our solution is generic. The solution works for all possible strings. But here, this problem is for DNA strings. So there are only 4 different characters. So we're not exploiting that information there. And also, here it's only 10 letters long. So exploiting this knowledge, this specific properties of this problem, we can write a faster solution by essentially encode the string. So if we only have 4 type of characters and the string can only be 10 letters long, so that means at most there are 4 to the 10, which is 2 to the 20, which is about a million. There's at most 1 million different possible strings. So we can actually instead of using a map to store whether a string, how many times it appears or whether it appears or not, we can use an array, in fact a Boolean array, to store whether a string appeared or not. So because there are only about 1 million of them, so what we need to do is we encode the strings. We convert this string into a number, so that every length 10 string map to a unique number. This is actually a little bit similar to parsing. So if you think about it, actually, you can view this as base 4 numbers. There are 4 different digits, A, C, G, T. We can interpret them as 0, 1, 2, 3, and then each string is a base 4 number. So this is my implementation of this. And this idea of encoding strings is as a number is actually very, very useful. So in fact, if you think about the unordered set and unordered map we used before, what they are doing is actually converting a string into an integer. So this is known as the computing hash code. So 2 different strings with a high probability they will result in different hash value. So then those hash value will be used to convert back into a index into an array. So in fact, essentially, a lot of the things that underneath the data structure are actually arrays. Not all of them, but a lot of them are arrays. So the hash table or hash map are essentially you use a encoding function to convert the string into a number. But we want to make sure that 2 different strings, the probability that they ended up with the same hash code is small, because when they do end up at the same, then that makes the accessing those slower. So anyway, so here we are encoding the strings. So I wrote this function, convert a character into a number. So this can also be done using a map. So I'm actually not totally sure of the performance Oh yeah, now I know. Actually, I guess the faster performance, the faster. I think the fastest should be simply use the indices into an array. So I should, instead of having the function, I can create a array of for all the characters. So I guess maybe up to length 128 will be enough, and then I just interpret each of the character as index into that array and return this number. I don't know how fast that will be. It's probably not that big difference. So this is the part 1 of the code. This is just some preliminary. I do have answer, and then I have this checking the size. So this part have the main things. So here I use 2 bitmap in order to save the use 2 bitmap in order to save the memory. So first I use a bitmap instead of a array of booleans, because I think a boolean array or vector of boolean by default, the implementation will at least allocate 1 byte for each boolean value. But if I use the bit set, then the internal representation will just use a single bit. So here the bit set is 2 to the 20, and I use 2 of these, one of them to record whether it has been appeared in the string, the other to record whether it has been outputted, because I don't want to output the same string twice. So I'm computing the value of every string, and that will be stored in the variable BP. And to help me compute that, I have a mask, which is I want the last 20 bit all 1 and the previous bit all 0. So we're going to use this later. So here my code try to make a computation of the code as efficient as possible. So after I have computed the code for the substring from 0 to 9, to compute the substring from 1 to 10, I want to use I want to reuse the computation I have already done. So I don't want to recompute that again. So this will speed up by a factor of maybe a factor of 5 for at least for this part, computing the code part. So I first compute the code for the first substring from 0 to 9. So this is essentially doing base 4 arithmetic. So each time I will shift left 2 bits of this, and then I will I guess I can do addition here as well. I can just add that value, but here I use bitwise OR, which is equivalent, because after I shift left, the last 2 bits will be 0. So and this function character to bits will only have the last 2 bits just be 0, 1, 2, 3. So OR and addition here is equivalent. So then F1 store that, well, I've seen this bit pattern, and then starting from 10, I will each time compute the new bit pattern. So to compute the new bit pattern, I start from the previous one, and I shift left 2 bits, and then I want to get rid of the highest 2 bits. Because I only need that highest 2 bits correspond with the character that I want to forget. So when I equals 10, the highest 2 bits correspond with 0. So I don't need that. So I do that by bitwise AND with the mask, because the higher bits are all 0. So this will clear out the higher bit, and then I add in the new bit. So then these 3 instructions compute the new bit code instead of doing a loop of 10. So then if it already appeared before, then that means this is a string that I have I have seen twice. I need to output. Then I check whether it had already been outputted. If it's not already outputted, then I will add it to the solution and then set the position for the output. And then of course, if I have not seen this, then I will set it to be true. So that's the logic. And let's look at this version. So So I think that's this submitted version. So I tried all this different version here. So it's not the fastest, I guess. Yeah, so it's faster than 99.6. So they are still, I guess, maybe once faster. So I suspect that might have to do with using this to make input more efficient. So in previous one, I noticed that oftentimes if I add this speeding up input, then I can get 4 milliseconds less. I'm going to explain this a little bit more, I think, in a later sample code, because this is a knowledge that's generally needed for competitive programming. And I think in terms of space, this is probably very efficient. We use memory 7.3 meg, so yeah. So I think we use less memory than everyone else. No, is it? Let me see. No, I get it. Let me submit this again just to see what. Okay, yeah, so it is, and let's actually add that input speed up code. So add that to the constructor. See whether that makes difference in terms of yes, indeed it shed the 4 milliseconds. So now we are the fastest and use the least memory among all submissions. Okay, so yeah, that's it for the first example problem.